5.2 trig word problems level 2. I've only got 2 of these problems. They take a little bit longer to solve, really longer to maybe draw the picture out. You're going to have 2 triangles in these problems. So let's try them. Number 1 says a boat is heading towards a lighthouse where Chandra is watching from a vertical distance of 115 feet above the water. Okay, Chandra measures an angle of depression to the boat at point A to be 8 degrees. At some later time, Chandra makes another measurement and finds the angle of depression to the boat now at point B to be 36 degrees. So it's moved in closer to the lighthouse. Find the distance from point A to point B. So we're finding this. Round your answer to the nearest tenth. Okay, I stole the pictures off of Delta Math. I figured that might be better than my drawing, but I find them a little bit confusing. We're talking about an angle of depression. So really the object we're going from is this lighthouse. Chandra's up in here. So remember, an angle of depression is looking out horizontally to looking down. So that's why this 8 degrees is right here. But remember I told you I copy that and put it inside a triangle. So I really would be looking at this triangle. Okay. And so if this is 8 degrees here, then I could also copy, since this is a transversal cutting through parallels, and put it inside here. But what that's going to do is I'm going to have the opposite leg and the adjacent, that's a tangent, and I'm going to find from this boat A to the lighthouse. I don't want that whole distance. I only want from the boat A to the boat B when it moved in closer. So I'll have to also use the triangle here from boat B to the lighthouse. And if this from the horizontal to here is 36, that means this is also 36. Looks kind of weird. It'd be better if it was back here. So from horizontal to here is 36. This horizontal to this same transversal is 36. So what I'm going to have to do is subtract away this leg to leave me with AB. Okay, so I'm finding this whole leg from A to L, subtracting B to L to leave me with A to B. Hopefully that makes sense. And so, let's set up the first one. We would have, we said tangent of 8 degrees equals opposite is the 115 for the lighthouse over, we don't know, we'll call it X. So I hope you're noticing or remembering that when I have X in the denominator, yes, I multiply by this, and then I end up dividing by tangent of 8. So really what's happening is these two things kind of swap places here, and that can speed you up. So saying X will equal 115 divided by tangent of 8. Remember, again, you want to make sure you're in the right mode. I'm using the same calculator, so I'm good. I get that distance to be about 818.27. But I'm going to leave that answer in my calculator. Okay, next triangle will also be a tangent problem because we have the same lighthouse as our opposite and then the adjacent leg. Here's our 90. So we'll do tangent of 36 equals 115 over X or over Y if you want to give it a different name. Really, to solve for Y, you're taking 115 divided by tangent of 36. And I get 158.28. So see why I'm subtracting this minus this to give me this distance. So I'll just steal these from my calculator, hit enter, and minus, hit enter, enter one more time, and it's the nearest tenth. This 9 is going to round up to a 10, so that actually makes this 660 feet. All right, one more. Ryan spots an airplane on a radar that is currently approaching in a straight line and that will fly directly overhead. The plane maintains a constant altitude of 6,300 feet. Ryan initially measures an angle of elevation of 15 degrees to the plane at point A. Sometime later, he measures an angle of elevation of 31 degrees to the plane at point B. Find the distance the plane traveled from point A to point B. Round your answer to the nearest foot. Okay, so again, picture might be a little overwhelming when you see it all at once, but here is Ryan on the ground. A plane is flying from way back here and keeping its same altitude or same height off the ground of 6,300 feet. So here it is here, and then it gets closer to Ryan. I'm going to highlight the triangle that's formed from Ryan looking up to the plane when it's at its first point A. And then we've got the angle of elevation is the 15 degrees. And so what I'm going to have to do here is, again, I'm trying to find here to here. But this whole triangle is going to find me from Ryan to where plane A's at. So I'll have to find that. Then I'll have to use the second triangle, I'll subtract, and that'll leave me with this. Okay, so another tangent problem of 15 degrees would be opposite over hypotenuse. Remember, you're just going to swap. So x is found by taking 6,300 divided by tangent of 15. And I get 23,511.92. Okay, and then do the other one. Tangent of 31 degrees, same altitude. Now it's a bigger angle of elevation because he's having to look up more, but same height off the ground. So tangent of 31 equals 6,300 over x. Yeah. And I got 10,484.96. I'm going to subtract those two things. And I get 13,000. Let's see, nearest foot to that 9 would make the 6 round up to a 7, so 13,027 feet. And that's it.